So I'm going to take these one by one. We're starting with carbohydrates. Plants in culture usually cannot meet their needs for fixed carbon. The fixed carbon is normally supplied by the leaves. We normally chop off the leaves. So for example, if you're using a shoot tip or we're using an axillary bud, we would chop off the leaves. So we need to supply the sucrose that would have been produced by the leaves. Another consideration is that in plant cell cultures we normally grow the plants at low light levels. It's expensive in order to produce light from electric light bulbs. So the typical full sunlight on a nice summer's day would be around about 3000 micromoles per meter squared per second. In a plant tissue culture growth room, we would typically be supplying light between 50 to 100 micromoles per meter squared per second. So it's only a small fraction of the light that plant would normally be experiencing. And this light is needed in order to make sucrose as a result of photosynthesis. One of the problems with actually producing what are called photoautotrophic cultures, that is cultures that can provide their own carbon by photosynthesis, is that we'd have to have a lot of lights there, and these lights actually generate heat. And the heat, we have to have cooling plant in our growth room to get rid of the heat which is generated from the lights. And for every unit of lighting that we use, we typically have to provide 2 to 3 kilowatts of cooling plant in order to remove a kilowatt of light, because the lighting is inefficient. So we normally add fixed carbon to our culture medium, and usually sucrose at 2 to 3%. You can use glucose. The first thing that the plant does before it utilises the sucrose is actually break it down into glucose and fructose. So glucose and fructose can be used instead, but sucrose is cheap and very easy to produce and purchase. So we normally, when you look at plant tissue culture media, you'll find that they typically would use sucrose. If you're using large-scale cultures, so for example a 50,000 litre fermentation, where you may be using large quantities of sugars, it's possible to use cheaper sources of sugars, for example corn syrup. But for example, for commercial micropropagation, you can go out to Tesco and buy a bag of sucrose, and because it's crystalline pure, it will be at least 99% sucrose, and the contaminants don't normally interfere with the micropropagation process. Now, for research purposes, I would normally purchase my sucrose from places like Sigma or Duchefer, which is a commercial production company in the Netherlands. But there have been occasions when I've run out and I just go to the local supermarket, buy a bag of sucrose. So it is possible to use cheaper alternatives if you're involved in commercial micropropagation. I've mentioned photoautotrophic cultures, and these are very rarely used because of the amount of heat generated by the lighting. It does have some advantages in that the medium doesn't contain sucrose. So if there are any contaminants land on the medium, they will be unable to grow because there's no carbon source there. It also makes the plants easier to transfer to the greenhouse. One of the problems with growing plants with high levels of sucrose is that the plants don't need to photosynthesize, and they tend to have abnormal physiology and anatomy. So for example, plants grown in culture tend to have very thin cuticles, they desiccate very easily when you take them out of the tubs that they're in. They tend to have stomata which remain open, so they tend to lose a lot of water when we transfer them to the greenhouse. And if you grow cultures photoautotrophically, they tend to be much more physiologically normal. However, there is a downside to this in that you need to supply very high light intensities. And we also tend to use high CO2 concentrations in our growth rooms when we're growing cultures photoautotrophically. So there are some advantages and disadvantages to photoautotrophic cultures. Inorganic salt formulations, these are all based on Hoagland solution, which is a solution which is used for spraying on plants or feeding plants in the greenhouse. There are a wide range of different inorganic salt formulations which are used, and these supply the macroelements and microelements for the cultures. We normally buy them in as spray dried powders. It is possible to make them up from the nutrients themselves, but there are a range of problems associated with this. For example, some of the nutrients may be difficult to dissolve, so you end up with insoluble precipitates in your media. Some of the components are problematical in terms of licensing. So for example, in my lab, I like to make up media for certain purposes from scratch. For potassium nitrate and ammonium nitrate, I have to get a license from the police in order to have these in my laboratory, because they can be used as explosives. So I have them locked away in a cabinet. Part of the requirement of the license is that they be locked away so that people can't readily access them, and I have to renew the license every year. So it's much more convenient to buy the media as spray dried powders. And if you buy in bulk, it's still relatively cheap. The vast majority of inorganic salt formulations are derivatives of two media which were made up in the 1960s, and these are Murashige and Skog medium, which is the most popular for shoot cultures, and Gamborg's B5 medium, which is widely used for cell suspension cultures. And they are quite different in terms of the nitrogen components in the media. So Murashige and Skog medium has potassium nitrate and ammonium nitrate, but B5 medium has no ammonium in it. And this can be quite important for some plant tissue cultures. Vitamins. The larger the explant, the less the requirement for vitamins. And if vitamins aren't there, then the plants will suffer, they won't grow as well. If they're there in excess, usually nothing much happens. So I tend just to throw in a vitamin cocktail of nicotinic acid, glycine, thiamine and pyridoxine and inositol, just in case. So like I say, if it's present in excess, it doesn't usually have any deleterious effects, and sometimes it's needed.